Hi guys, good morning. So in our previous class we discussed about classes, inheritance, how to override a function and how to make use of the function which is already defined in the parent class, and also we even saw how to use the protected accessor keyword and how to make use of it to even import certain functions from the parent class. So in this class let's discuss about polymorphism. So basically we will use polymorphism such that during runtime you will be able to differentiate between different classes, how to instantiate. So you will write a generic class, but on the fly, based on your use case, based on your needs, appropriate classes will be invoked. For instance, let's consider a factory. Let's consider a pizza factory. So whenever we go to a factory, we pay for certain kind of pizza and then we wait for our pizza. So at the outer level we pay for certain kind of a pizza and end result will be our appropriate pizza. So I will show you few examples on how to make use of this pattern, and every language has their own conventions. I'm just giving you an overview in general, and the syntax which I'll be showing you, it will be in terms of Ruby, and accordingly you can use the same thing for Java, Python or any programming language. It is a generic solution. So accordingly what you can always do is you don't have to mix up all the code in one class, and this will be a very good example of differentiating the responsibilities to different classes. Like a tomato pizza can have its own code, and a burger pizza can have its own code. Likewise, a margarita pizza can have its own code. So every pizza will have its own functionalities. The common functionalities can be put into the parent one, but however the varying constraints, varying functionalities can be put into its own classes. So that way whenever you find an issue, it will become very easy to debug and add the code in its associated class. So this is called separation of concerns. You can also call it as a dynamic factory pattern, or it can also be a loosely coupled pattern. So there are multiple terminologies: separation of concerns, polymorphism, loosely coupled pattern, dynamic runtime, polymorphism, and there is also no collision between the classes, debugging, separation. So these are some of the important terminologies which you will be going through, and these things will be always helpful for you in the future whenever you start coding. Okay, so let's get started. So to begin with, we can identify the list of classes that we might need. Okay, we might need a factory class, and okay, so to give you few examples, let's consider a margarita pizza class. Let's also consider a cheese corn pizza. What else? Okay, let's also consider a tomato cheese pizza. So in all these, let's assume there is a common functionality which we can inherit into all three classes, and we can name that parent as a pizza class. For instance, let's assume all these will have its own associated names, right? So margarita will have its name as margarita, cheese will have its own name, and likewise tomato. So the name is a common pattern in all this, and the cost will vary and its color varies, right? So for now we can assume we can have these three, since we are now going to inherit from the parent class. So let's inherit from the parent class. So all these will become sub patterns. Now okay, now let's assume we have a common function to display its name. So the name is name of pizza is name, and cost is cost, and color is whatever color that we are going to assign. Okay, so these are the common functions. Now let's override them in here. So what we shall do is, let's assign the name as Margarita. Likewise, its cost, let's put it as $500. Okay, it will be too much. Let's put it as $50. And the color of Margarita is cream. Likewise, what we can do is okay, and likewise this is cheese corn, and let's assume this is yellow in color. Now tomato is, let's make it 30 and let it be red in color. Now if someone is going to order a pizza based on whatever they require, accordingly, okay, let's return, instead of this, let's have a function called getPizza. You pass in a name, and based on the name, let's, if name equals Margarita, name equals tomato cheese or new. Likewise, name equals what else, Margarita cheese corn. We gave one tomato. So if the name is cheese corn, then we will provide it. Return based on this. Else. So in this case, what we are doing is, okay, we don't even need to return. Else. So the shortcut to align the code is Command Option L in case of Mac. Likewise, every different platform has its own shortcuts. So a lot of shortcuts are given in here. You can actually, over a period of time, once you start using it, you will be able to get accustomed to it. So I would always suggest learn the shortcuts so that it's handy. Your typing speed increases, coding speed also increases, and there will be a lot of advantages in doing so. So coming back, so our factory code is ready. So whenever you ask for a Margarita pizza, it will give you Margarita, and whenever you ask for a tomato, it will give you its associated tomato, and likewise whenever you ask for a cheese, it will give you cheese. If you ask for any invalid pizza, it will throw an error. Okay, so now let's also okay, now let's invoke, okay, factory.get instance. So in this case, we need to make this a class method. Remember in the previous class I had mentioned, if you are not instantiating any object, and in such a case you can make use of class methods. So in this case we are making use of class method. So I'll just increase the font. I hope it is clear. So get instance, you can clearly see factory.getPizza. Let's pass tomato, when we call this, we will get its associated instance, and since every child class is inheriting from a parent class, it already has the display function in there. So if you just call this, you should be able to get the output now. Let's try to execute this. I'm already inside this class, so okay. Display. Okay, nice. There you go. The name of the pizza is tomato pizza. Its cost is $30 and its color is red. Now let's try cheese corn. Okay. See, the name of the pizza is cheese corn and its cost is $40. Color is yellow. Likewise, let's also execute one more example of margarita. So you are instantiating margarita because it goes there, checks for margarita, yes, so it returns this instance. Since we are inheriting from the parent class, display function is available, so if we execute, yes, there you go. The name of the pizza is margarita, cost is 50 and its color is cream. Now if I pass any other invalid names in here, obviously it will throw an error. We already saw. Let's try and see what it gives. See, not implemented error. This is because we have just defined only three kinds of pizzas. Any other pizza name you pass in, it will throw an error. So basically this is how we can deal with the factory pattern, wherein we can write a generic code, and during runtime it will be able to instantiate the appropriate class based on the business logic. So I hope you like this example. Please do like, share and subscribe to my channel. If you have any questions, please put in a comment and I'll be more than happy to resolve the same. Thank you guys. Thank you.